Here are two uilleann pipe chanters, standard sized and a fair bit smaller. I'm going to play the standard size one first and then the small one to see what it's like. Now let's switch over. Well, actually we'll switch the chanter, but we'll use the same reed. So, even though it's a much smaller chanter, it's playing at the same pitch. The question is, how is this chanter much smaller than this one, but it plays the same notes? Well, if I say that acoustically they are the same length, you might be able to guess what's been done. The small chanter has the same starting bore as the big chanter, but we coil it round inside. And that allows us to bring the finger spacing down from a traditional 33mm or thereabouts to, in this case, 24mm, without affecting the pitch. It still plays in concert D. I can hear a slight difference in tone, as you may be able to, so the coil is affecting the acoustics, but the sound and behaviour between them is very close. Let's think about an application of this. For almost every other common instrument, we accommodate young learners. We have quarter-size violins and cellos, we have flutes with curved head joints to reduce the reach, and now even lightweight plastic clarinets for small hands. But there has never been anything for young learners of the uilleann pipes. There are 5 barriers I can think of that tend to stop youngsters ever picking up the uilleann pipes. First, the standard chanter is too big, so you see things like young learners struggling to play using their fingertips because it's the only way they can reach the holes. The second barrier is keeping the reed working. It's fiddly and requires practice and experience. The bridle is crucial, but it's tricky to set up with fine-nosed pliers. Sometimes it seems like the reed behaves differently in every single room, and the bridle has a habit of sliding down the reed in the middle of a performance. Next, it's hard to get a reed that plays well in a given chanter. I regularly hear of people needing to post a chanter to a reed maker to get something custom made and fitted. There's also the airflow connections to contend with. We have to avoid air leaks because they're so problematic, but we also need to connect and disconnect things for transportation. So we use hemp binding or cork for the joints, and both of these require maintenance. And last but not least, the cost of a starter set is high just to try something out, and you might have to factor in a long waiting list when time is marching on. Let's look at how the situation can be improved. First, a chanter like this 24mm spaced one of course solves the fundamental problem of the holes being too far apart. A young learner can jump straight in with a standard grip, relaxed hands on the chanter, covering the holes where the fingers naturally land. In addition, despite its complex internal geometry, this chanter is actually inexpensive to make because it's 3D printed. As far as I know, it would be difficult to create a coiled, tapered bore any other way. 3D printing allows us to repeat the complex bore geometry accurately every time. And because it's inexpensive, the instrument can grow as the learner grows, moving from 24mm to 26mm to 28mm and so on by loosening the coil slightly inside on consecutive instruments. Now let's look at the mechanical side. The chanter uses a universal cap and reed mechanism, so you just replace or exchange this section when moving up to a larger instrument. It also uses a fairly sophisticated set of components to make tuning easier. We can extend or shorten the length of the conical bore to accommodate different reeds. So if we have a working reed with a staple of suitable diameter, then we're effectively adjusting the chanter to fit the reed, which I think is much easier than adjusting the reed to fit the chanter. And this bridle can be adjusted easily, reliably and reversibly with a screwdriver. Apply more or less lateral pressure like this and move the contact point up and down like this and then secure back in place. There's no hemp binding on the joints. I haven't used binding or cork in about 8 years now, and I can't say that I miss it. Everything here screws together in an airtight way, using O-rings for the seals. The maintenance headache of traditional connections is absent. To keep the rest of the cost down, we can choose functionality over form for the bags and bellows. This is a budget bag and bellows combination, and they work fine. The bag is a synthetic material, it's airtight, and it's not too large. In my view, bags above a certain size are less effective because of the old pressure equation from physics. Pressure equals force divided by area. A smaller area gives you more pressure for the same elbow force. For the bellows, I measured them recently as delivering 2 litres of air per stroke, which I think is respectable. They fill this bag in just 2 strokes. And I think waiting lists shouldn't be an issue. The overall production process can easily scale horizontally. The next stage is to roll these out and get feedback for further development. Talking of which, I'd be pleased to hear your feedback in the comments.